Okay, good morning, everyone. Mm, my dear students, uh, I'm taking lecture from home by using mobile Wi-Fi. So internet connectivity might be poor. So if it disconnect, stay connected till the time over, maybe up to the 12:30. So everyone, okay. So we'll start the next topic. In the last lecture, we have started with battery charger. So I'll just give. So as I already told you, very difficult to conduct the lecture from home because of a very poor internet connectivity. Okay. So again, it shows internet connection is unstable, but still I'll try. Okay. So battery charger that we have started in a last lecture. In this circuit, this first part is nothing but a rectifier. Okay, this is a transformer, step down transformer, which converts 15 volt. Then two diodes forms a rectifier. Okay, the output of this rectifier is given. See, the output is given to P and one terminal given to the Q. Right. So whatever positive pulse will apply between P and Q, what happens immediately? The voltage at point O increases as soon as the voltage is greater than zero point 0.7, diode D3 forward bias. Okay, and this will try to trigger the SCR, but only zero point 0.7 is not sufficient to trigger the SCR. So again, voltage will increase, and whenever the voltage at point O is sufficiently high to turn on the SCR1, SCR1 will trigger, and then current start to flow through SCR1, R2, and battery charges. Okay, then battery start to charge. So battery charges uh, up to the maximum called 12 volt. So for every positive half cycle, the same cycle repeats that the voltage at the O will increase. Then diode D3 turns on, and which will trigger the SCR1. SCR1 once triggered, it will charge the battery. Okay, whenever the battery is fully charged, okay, this will happen when S1 is on. I just forget to tell you, S1 should be on. This is actually a charging button, we can say, on button for charging. Okay, so this button or switch is on. After that, this will happen. So whenever the voltage across battery is equal to 12 volt, it means that battery is fully charged. Then the voltage at cathode is a 12 volt, right? And we are connecting here a 12 volt Zener diode. So voltage V, voltage at O should not reach to the or greater than 12 volt, because as soon as it goes to 12 volt, Zener diode turns on, right? So voltage at the O, if is equal to 12 and voltage at cathode is also equal to 12, then SCR1 remains off. It never conducts. Okay, so SCR remains off. So once battery fully charged, then the circuit is automatically turns off as your switch is still on, but SCR never conducts. So overcharging of a battery is avoided. So this is called as automatic charging. Automatic is called because once the battery is fully charged, then the circuit automatically disconnect the battery. It means your SCR never turns on. If SCR never turns on, then battery will never charge, right? That is called overcharge. Again, if battery is discharged below 12 volt, say it's 11 volt, again same thing happen. The voltage at O is greater than 11 volt, SCR turns on, right? If it is 10 volt, then voltage across at point O is 10 volt, SCR turns on and battery will be charged. So this is a battery charger, and battery charger is required everywhere. Okay. So the explanation of the same circuit is given for your reference. You can read later on. I will forward these PPT as soon as this unit is over. Okay. So next topic is electronic lamp ballast. Okay, simply we can call choke, right? But whatever choke we are using in old fluorescent lamp, that is basically a electrical. Okay, so this problem maybe continuously arise. So I just request you to give your attendance first so that I can have your presentee if suppose it again break and if not connect again. Okay, but you should stay till the 12:30. So whenever the internet will poor, it will disconnect, but again it will connect. Okay, so during this particular time, you just give your attendance in a chat box. Okay, so electronic lamp ballast. Uh, Normally, electrical lamp ballast we are using. Okay, electrical lamp ballast we are using for old fluorescent lamp, right? But nowadays that electrical ballast, basically the choke or a coil, so that help to the fluorescent lamp to turn on. So uh, that electrical ballast or choke is replaced with electronic ballast. Nowadays, only electronic ballasts are available in the market. That electrical ballast are now replaced with all the electronic ballast. So you can see here it's a conventional fluorescent lamp with the inductive ballast. This inductive ballast you can call as a choke, right? And this is your lamp. But you can see here electronic ballast. So what is the need of electronic ballast and etc. That we will see first. See, lightning consumes nearly 15 to 20% of energy in residential buildings and nearly 30-35% in commercial buildings. Fluorescent lamps are 3 to 4 times more energy efficient than incandescent lamp. Okay, the energy efficiency of fluorescent lamps can further be boosted up to 20 to 30% by operating at higher frequency, right? Higher than 25 kilohertz frequency. So same fluorescent lamp, as we know that incandescent lamps are now totally outdated from the market. Everywhere you will get a CFL or maybe a CFL or LED lamp or maybe a maximum tube, that is fluorescent tubes, right? So incandescent lamp, definitely it's a heavy energy consumption. So, and even the intensity of that lamp is not as good as fluorescent lamp. So energy of a fluorescent lamp, that is approximately 20 to 30%. Again, we can increase or boosted by using electronic ballast, which works on 25 kilohertz frequency. Conventional fluorescent lamps use an inductive ballast, also called as a choke, in series with the stable operation with a 50 hertz source, as shown in figure, right? So this is our normal conventional fluorescent lamp with inductive ballast. Nowadays, this type of uh, fluorescent lamp is not available in your market, but still in our home, we're having some old tubes. So in that tubes, we are again still using electrical ballast or called as a choke. But nowadays, all fluorescent lamps are replaced with the electronic ballast, right? So this electronic ballast will works on high frequency. So what is exactly in the circuit? Uh, that is 50 hertz, 230 volt supply we are giving. Then power factor correction circuit is there, so that the maximum reactive power will be removed and active power will be feed. Then uncontrolled AC to DC converter. Uncontrolled AC to DC converter. So this will be convert 50 hertz AC into DC. Then there will be a filter and then a high frequency inverter. This circuit is a high frequency inverter, and this high frequency inverter is used to work the lamp, right? So this high frequency inverter, it means basically the circuit is continuously on off, but the frequency is very large, so you will see the lamp is continuously on, right? So this circuit will definitely save the energy as compared to the electronic balance, because this circuit is continuously current flowing through the lamp because of this electrical or electric ballast, or you can say choke, that is provided the AC source to the lamp continuously. But this high frequency inverter is continuously on off, so that the lamp that energy is saved. See figure block diagram of modern high frequency fluorescent system. The uncontrolled AC to DC converter with a filter is followed by high frequency DC to AC inverter. That is class E resonant inverter can be used here. This is not a part of your syllabus, that's why we are not seeing, but it is one of the type of inverter which is very low cost inverter, class E resonant inverter. So the switching frequency of inverter lies in the range of 20 to 40 kilohertz and up to the 60 kilohertz or higher. The current from the source has a very poor power factor. So power factor correction is required. That is, current from the source has very poor power factor. So power factor correction is required. That is, okay. So power factor correction circuit is required. Then EMI filter prevent the, again internet connectivity is very poor. EMI filter prevent the conducted electromagnetic interference signal from being fed by the AC line. Okay, so that is given here, right? Then, so this circuit actually very simple circuit. Normally, this circuit consists of first AC to DC converter and then again DC to AC converter. So DC to AC converter with a high frequency, that is nothing but inverter, and that is the basic use of inverter circuit, right? You can convert this 50 hertz frequency to, okay, I think very poor internet connection, so that's why our connection fails after every 2-3 minutes, but still we'll go, we'll try for complete the lecture. Okay, so this circuit first part is power factor correction. Again it shows poor internet connection. Okay, very poor power factor correction of a current at is input source current, so power factor correction is required. Then AC to DC converter, that is a conversion of your 50 hertz AC to DC. Then filter, if any high peak uh, value of voltage or maybe EMI interference, that will be removed with the help of this filter. And then high frequency inverter, right? So this high frequency inverter, so your tube or your fluorescent lamp, if it works at high frequency, then definitely the efficiency of that lamp increases, even the intensity of lamp increases, and it requires a less power. That is the advantage of electronic lamp ballast. Okay, so this is the next application, induction heating. Okay, I think this is the last application from your syllabus, unit number 6. So induction heating, everyone knows that induction cooking or induction cooker might have seen by most of the students, and maybe it is available at your home. So what is the basic principle of induction heating? That is important. See, one most important thing that I just forgot to say you, the applications, your 6 unit is applications. So again, electronic lamp ballast, AC to DC converter, and DC to AC converter, right? That is application of these circuits we are using here. Even in this particular charger, again we are using the same thing, right? Application of SCR and other circuitry. So these are the applications of previous topics what we have seen in unit number 3, 4, and 5. Okay. Now induction heating. Induction heating operates on a principle of induction. Induction means what? In order to heat the electrically conducting material, right? So material to be heated is known as workpiece, right? If you connect a coil to the iron workpiece, and if you pass the current through that particular coil, then definitely that uh, workpiece or maybe a metal part or maybe a iron is heated. As we all everyone knows that this kind of principle we are using in a heater, right? So that is the basic principle. So material to be heated is known as workpiece, and the coil wound around it known as a work coil, right? So this is a principle. See, this is a metal piece, work piece, and this is a coil actually, right? The difference is only we are applying here a high frequency AC voltage, right? Not a 50 hertz line frequency. We are applying here, we are applying high frequency AC voltage. Again, we get high frequency from the circuit, same AC to DC converter, and then again DC to AC with a higher frequency, right? So what happens that we will see first, the work coil will act as a primary winding, and the workpiece will act as a short circuited secondary winding of a transformer, as shown in figure B, like this. Okay, this will act as a, so this coil acts as a primary, and this workpiece acts as a short circuited secondary winding, right? Because the secondary winding is closed, so that's why it is called as a short circuited secondary winding, right? Then when high frequency AC voltage is applied across the work coil, the magnetizing current flow through it. This will generate flux in the workpiece and induce voltage into the workpiece. As already we know that when we apply current through this particular coil, primary coil you can say, then because of that the magnetic flux is produced across the coil. This will magnetic field produces, which will produce the heat in the workpiece, and because of that the EMF is induced in that workpiece. Okay, so that is a simple principle. Then exactly what happens that we will see, since the workpiece is closed on itself, eddy current flows into it as shown in figure. So see, this is the workpiece, AC voltage, then this is called as a work coil, and this is a workpiece, and these are called as a eddy current, right? What is the eddy current actually? When we apply current or maybe a current to the coil, and if you place a conductor in that particular coil, then what happens, the magnetic flux is produced in that workpiece, and then again the EMF is induced, and once EMF is induced in that coil, again magnetic field is produced across that workpiece, and because of that again the current will flow through that workpiece. That is called as a eddy current. Okay, so that eddy current will start to flow. Okay, the workpiece will be heated up to or up due to the finite resistance offered by the workpiece to flow of eddy current, right? So heat loss in the workpiece is normally confined to surface of the workpiece due to the skin effect. It is tendency of a current to get concentrated on a surface. Skin effects is observed at higher frequency operation. Okay, so what happens exactly? When the current passes through this particular coil called as a work coil, then the flux is induced across this work coil. This will produce heat in the metal piece. Once the metal piece is heated, then the EMF is start to induce in a metal piece. Once EMF is induced, automatically the magnetic field start to produce across this workpiece again. Okay, and that magnetic field nothing but your eddy current, and once eddy current start to flow, definitely eddy current will heat this workpiece highly, right? So as your current increases, the eddy current increases, so that the induction or maybe work metal piece or workpiece heated. You can see here this type of application, that is induction cooking. So rectifier and high frequency inverter, this induction coil, right? And this is practically metal pan what we have placed there. So automatically what happens, this metal pan get heated, okay, and then you will get, so you can maybe adjust the heating of this metal pan by controlling the frequency, right? So if you decrease the frequency, the flux produced in this coil is decreases, automatically the metal piece maybe decreases its heating, so automatically eddy current decreases. As eddy current decreases, then the workpiece is not heated up to that value, right? So by simply changing the frequency, we can control the heating to the workpiece, right? These are the typical circuits used in induction heating. So again, same AC line, 50 hertz to 30 volt. Power factor correction is required every time because the input current, source current is having maybe a lower power factor. So power factor correction is required. Then uncontrolled rectifier, okay, it is DC converter, again filter, and then voltage source inverter. This is one of the type. The second type is uh, that is resonant inverter. Same type of circuit is used in electronic ballast, right? So electronic ballast, simply the output is given to the fluorescent lamp. Here the output of this particular inverter is given to the coil or maybe a metal piece, so that metal piece get heated, okay? So circuit is very similar to the electronic ballast. So any one type of circuit, this one or this one, will be used in induction heating. The concept is given here with the help of these diagrams, right? And this diagram shows actual circuitry in induction heating or induction cooking, right? And this is one of the application of induction cooking or induction heating. So this is the end of unit number 6. All applications I have covered. Uh, in next lecture, from next lecture, we'll just review the unit number 6 or unit number 5. First, we'll review unit number 6, and then we will review unit number 5. Then we will review unit number 4 one by one in the next 3 lectures. So last 3 units are again important. Your exam pattern is already posted by Dige ma'am on your group. So you know that how much syllabus is there for your online examination. Uh, Most of the chances is online examination, but the syllabus for online examination, I think all 6 units, right? So first 3 units as well as last 3 units, all 6 units are equally important, right? So already we have covered online examination, test 1 and mock in same exam on first 2 units, right? Even first 3 units. Now I'll just prepare online examination or maybe a test on last 3 units so that you will have maybe a more preparation for online examination. Then we will design a question bank. The first and second online test or whatever we are already conducting, I'll just uh, again reopen the same examination so that you can give the exam again. The marks will not be considered, but you can give the exam. And then I will prepare the examination on last 3 units so that 30 questions in first test already we have conducted. Even I'll conduct test 1 on unit 1 only, in which I have given 20 questions. So that 20 questions, then 30 questions on 2 units, then again 30 questions on 3 units. So 30, 20, and 20, approximately 70 questions already I have given to you. Again, I'll prepare 30 questions on last 3 units so that it will be approximately 100 questions for your preparation on these 6 units. Even university will provide you the online access, maybe practice test before conducting the final examination. So maybe examination form filling is, I think, started or not, I don't know, but your examination will be conducted in the second week of December, or maybe a maximum after 15 December. The schedule may be given very shortly. So examination is definitely online. Even you have to submit your practicals and your assignments by hand, right? So you have to submit that in a college itself. Whenever the college will reopen, uh, that is required. And even practical, already I have posted 7 practicals on YouTube. 2 3 times I told you, uh, just look the practicals from YouTube, because there will be a oral examination. Practical examination nahi hona, but definitely there will be a oral examination, and that examination is totally depends on the practical, right? So you all are again instructed to see all the 7 practicals already I posted on YouTube. Okay. Okay. So everyone goes go to the YouTube, see all the videos available on a practical. Last practical I'll just post you on Monday or Tuesday. So all 8 practicals are there for practical examination. Any one question from that 8 practicals will be asked. So everyone, okay. So everyone should see the practicals. If you are having any doubt, you can ask me. Okay. So everyone should see all the lecture videos already I posted on YouTube. Even last 2 3 lectures or 4 lectures are remaining. So I'll post that lectures as soon as on YouTube. So you can watch the lectures. Uh, Even you can watch the practical videos. Practical video is very important because the questions will be asked only from that video. Okay. So whatever I explain you in that video, I'll just ask the question on that video only. So everyone should see the practical videos and even the lecture videos, so that it is very helpful to the you for. Okay. So last 2 3 minutes are remaining. Internet connectivity is very poor. So we will end the lecture now. But everyone should watch the video, practical videos till Monday. I'll ask you questions on practicals in a Monday lecture. Thank you. Thank you very much.